Welcome back. Today we're going to explore what's actually happening when objects are making sound. Grab your pencil, your journal slip, and your science journal. So in the last lesson, you developed an initial model for how the truck speaker shakes the window that we saw far away. Today I want us to focus on the first part of the model, right here, to figure out what's happening when speakers, or any other sound maker for that matter, make sound. How do you think sound sources like instruments and speakers make all those different sounds? I mean, what would you expect to see if you looked closely at these sources while they were actually making sound? Well, you're in luck because we're going to observe objects when they are actually creating the sound. And I have a ukulele right here. Watch.
What I have here is a ukulele. It's sort of like a small little guitar. And I want you to pay attention to what happens when I have this instrument make some sound.
All right. How did the string look when it was being struck by my finger? Yeah, you probably saw the strings move back and forth until eventually it stopped and it became quiet. But you know what I'm thinking? Does a drum move like the string? Does a speaker like the one in the truck move like this? What about a xylophone? You know, I bet if we had footage and slowed it down, we could see if there was anything happening too fast for our eyes to see. Well, you're in luck because I have some slow motion video of those three sound makers. And as we watch the video, I want you to put your noticings on your journal slip. Watch what's happening to the object or the sound maker. Here's the drum. The stick hits it. And now take a look at the drum skin. What do you notice? What do you see? What patterns? Okay. I also have slow motion video of a speaker, like the one in the truck. Here, take a look. What do you see as it's actually producing the sound? What pattern do you notice? Okay, I have one more. Look at this tuning fork. It's almost like a xylophone bar. Let's watch. This ball strikes the tuning fork. And then what do you see? The tuning fork is making sound. But what do you see as it's making the sound? How is this object behaving or moving? Okay. So take a moment to finish all your noticings. If you need to rewind, that's fine. So what did you observe? Let's start with the drum. Did you see that the drum skin was bouncing up and down like a trampoline? I mean, in the speaker, it was moving back and forth. And the tuning fork, when the ball hit it, the one bar it moved and then you saw the other bar move and then both bars were moving back and forth. Now, what was similar about the motion of these three objects when they were making sounds? Take a moment to think. Yes, you had to hit them, apply a force to get it started. That force caused the object to change shape, to move back and forth. The force transferred energy to the object that caused the object to move and change shape. The only thing that was different was that some of the objects, like the drum, were moving up and down, and some others were moving left to right. Now, how did the shape of the objects keep changing after we were done striking or plucking them? Here, we can look at the video again of the drum in particular, right? We see the stick hit it, but now the force is removed, and take a look. The drum skin moves up like a mountaintop and then dips in like a valley. The material is changing shape, moving up and down, up and down. And when the object changes shape like this, we would actually feel the object, feel the drum. We would say it was vibrating. When scientists say something is vibrating, they mean that it's moving up and down or back and forth repeatedly. And understanding why and how objects vibrate helps us better understand how that object creates the sounds that we can hear from a distance. So I think we can revise our model with the data that we gathered from today. Right here, we can better explain what's happening when a sound source is making sound, that first zoom in of our model. Let's do that in 5 panels. We'll use the drum as the example. First, before there is sound, the drum skin, you see right here, is laying flat at what we call the start position. Now, the drum stick applies a force, a push, on the skin, causing the skin to bend inward from the start. And in that moment, energy is transferred from the stick to the drum skin. Now, when that force is removed, the drum skin moves up above its start position, like this mountain. And then the drum skin will move back and forth repeatedly. And it's going to move less and less over time as it loses kinetic energy. But the drum skin eventually stops moving, goes back to its rest position, and there's no sound anymore. So this back and forth movement past the start position is what we mean when we say vibration. You can see that labeled right there on the model. And now this model can be used to explain how any instrument, how any sound maker makes sound. Here, even this one, it can explain how this guitar string is making sound. I'm just going to go right here. You can see that when a person's finger pulls the string and applies a force, the strings move back and forth from the start position. This movement back and forth is a vibration. It's when that movement back and forth is happening that we hear the sound. Now I want you to take a moment and use the model we developed for the drum and apply it to this guitar string. How do the guitar strings move to make sound? Show what's happening in 5 panels using pictures, words, and labels. You know what I would do? I would pause the screencast, go back to the screen of the drum model, and use that to do this model. Do that now. So we've been some pretty cool science today. We filled in details about our phenomenon. Today, I want you to submit your journal slip so that I can see evidence of your thinking and your modeling. Till tomorrow, keep thinking and keep learning.